Frequency and woo. Frequency is defined as typically number of repetitions in a minute or in a time frame. So you can have, 10 repetitions per second or 10 repetitions per minute or 10 repetitions per hour. So that denominator needs to be watched because it can confuse you if you play around with these, and people do. So, what is frequency? I just explained it. It's a recurring event you can measure. The climate has a change frequency. Light has frequencies. We see those frequencies as colors. That's what makes a rainbow, is a interaction with the sun's light or other very bright lights. You've seen them around street lights with the atmosphere around it, and it can make a halo looking thing. The colors in there are caused by the frequency of the photons that you're seeing. So, trained months of, years of frequency from 0 hertz, that's basically dead. But that can be a DC voltage. So it can have potential, but not a frequency, right? Then we get up into 60 hertz, 60 cycles per second is wall frequency in America. If you go to Europe, it's 50 hertz or 50 cycles per second, which is a little different. 50 cycles per second has less average energy than 60 cycles per second. But they well make up for that by using twice the voltage. So they inherently have a more efficient transmission system because of that. That would be another video. So frequency, I went up to 0 hertz, right? Is a calm. There's no waves on the ocean. There's no patterns to be seen around. It's fairly calm out. As the frequency increases, you can begin to hear it. Elephants can hear VLF. Submarines talk on ULF and ultra low frequency and very low frequencies. Another video. So these low frequencies travel through the ground and through the earth and through a solid medium fairly well. They're not traveling as photons, they're energy still, but they're traveling as a concussion wave, as a sound wave through whatever materials are near. The higher frequencies won't do that. They stop being able to penetrate or interacting with solids and go around them, or they interact with them and burn them or whatever. So frequency 0 to terahertz now we can measure. Radar is way up there in the frequency range. Radio is below radar in the frequency range. Your cell phones are playing in between those ranges, which makes their energies questionable as to what they can do because of interferometry and how particles interact with other particles in nature. Now, I've talked a little bit optical frequencies. We see colors of the rainbow. Okay, those colors go into very finite, discrete wavelengths, and we see those as hues or different colors, or we see them as a multiple of colors and interpret them differently. But no matter what color we see, the frequency from the light source is the colors from the light source is the same. When you get up into high energy particles, very high frequencies, we don't measure those necessarily in frequency, but they have a frequency. We measure those in energies, electron volts. And yet that frequency is still there. It's part of the equation. For a photon, which, depending on where you argue at, is a massless particle, which used to not be able to exist, but it can now. messed with math. You can't divide by zero. So if something has no mass, E equals mc squared falls apart when you start to do transitions to the equations. So frequencies, we talk about them in different ways. Everything that we have has some type of, every molecule has a resonant frequency. Every compound has a resonant frequency or multiple resonant frequencies that can interact with it depending on the particle going by with that frequency. So this gives you no idea of how complicated this all is and how easy it is to stick a woo in. More to come.